Let's understand the meaning of the multiplier in the Lagrange multiplier method. Consider the function f of xy to be equal to the product of xy, and we want to find the maximum, for example, and the minimum of this function to the subject to the restriction x squared plus y squared equals to 8. We construct a Lagrange function, which is xy plus lambda times 8 minus x squared minus y squared, and this lambda is called the multiplier. And we solve it as usual. The partial derivative with respect to x is y minus 2 lambda x. The partial with respect to y is x minus 2 lambda y. And the partial with respect to lambda, x 8 minus x squared minus y squared. Have to equals to 0. Both are equal to 0. Okay, consider the first equation where y is equals to 2 lambda x, and replace on the second one, and we have x minus 2 lambda times 2 lambda x equals to 0, or x minus 4 lambda squared x equals to 0. X common factor of 1 minus 4 lambda squared equals to 0. That gives x equals to 0, but if x equals to 0, from this equation here, we get y equals to 0, and then x squared plus y squared will not be equals to 8. So we should go to the other. 4 lambda squared equals to 1, where we get lambda equals to 1/2 and lambda equals to minus 1/2. Thus, we have two cases. First case, case 1, lambda equals to 1/2. In this case, again, because of the question mark with the star here, we have that y is equals to 2 times 1/2 of x equals to x. And so x squared plus y squared becomes 2x squared equals to 8, x squared equals to 4, x equals to 2 with y equals to 2, and minus 2 with y equals to minus 2. And we got 2 points, the 2, 2, and the minus 2, minus 2. Now, on the second case, we have lambda equals to minus 1/2, and we have y is equals to minus x, but the part of x squared plus y squared doesn't change, so we get two cases, x equals to 1/2 and y equals to minus 1/2, 0.3, 1/2. Sorry, this is a mistake here, it's not 1/2 but 2. Let me erase it and go back over it. X equals to 2 and y equals to minus 2, 0.3, which is 2 minus 2, and x equals to minus 2, y equals to 2, 0.4 equals minus 2, 2. Now we go back to the function f of xy, and we check. F of the 2, 2 is equals to f of minus 2 equals to 4, and f of 2 minus 2 equals f of minus 2, 2 equals to minus 4. So we have two maximum at the points P1 and P2, and two minimum at the points P3 and P4. Now, what is the meaning of lambda here? Well, we got two values for lambda. On the first case, lambda was equals to 1/2, and here lambda was equals to minus 1/2. Suppose that we have the same problem, namely, we have to find the maximum and minimum of f of xy equals to x times y, subject to the condition x squared plus y squared equals to 9. And here is where lambda comes into. Let me write it first clearly in blue. Lambda is approximately the change in the value f of the maximum or minimum if the restriction increases by 1 unit. So in particular, we have for the maximum f of p1 or p2 is equal to 4. So approximately under the new condition of x squared plus y squared equals to 9, we should get f of the new maximum should be approximately, well, 4.5 because lambda is 1/2. And for the minimum, f of p3 or p4 equals to -4, and under the new restriction, f of the new minimum should be approximately 4 minus 1/2, which is minus 4 minus 1/2, which is minus 4.5. Well, this case works very well because in this case it's not approximately, but exactly. If you do the computation, what you get is like for the maximum, when lambda, for the maximum, you get that x is equals to, well, for the maximum, we have x equals to y, and doing the computations again, we have x squared plus x squared equals to 9, from where x equals to plus minus root of 9/2, which is plus minus root of 9 divided by root of 2. And the function f of xy will be in this case f of 3 over root 2, 3 over root 2, or both minus, it doesn't matter. That's 3 times 3 over root 2 times root 2, so the 9 over 2, which is exactly 4.5. And similarly for the minimum, you can check that you get minus 4.5. But let's recall, because not always you get exact, but the value is, suppose you have a problem of maximizing or minimizing, doesn't matter, a function subject to a restriction, some expression of xy, blah, 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 equals to c. And your maximum value, for example, f in the maximum is equals to a with multiplier, whatever, some small amount, L. Then, if we get our restriction increased by 1, xy, blah, 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 equals to c plus 1, we'll have, for the new maximum, the value will be approximately the old value in the maximum, a, plus the multiplier, L. Let's see this with GeoGebra. Problem which we just did with the tablet, not paper and pens, but the tablet. Let's see we can look at it in GeoGebra. We wanted to maximize or minimize this function subject to the restriction x squared plus y squared equals to 8. Let's put that restriction in 3 dimensions. It's a cylinder, and this point here around the 4 is the maximum, and below we have the minimum. So just to see graphically, let's remove the cylinder and put our restriction on the plane. Now what we are going to do, we are going to keep moving the function values up and down and see what the level curves of this. Here you can see the level curve. It corresponds to 2 branches, which you can look at it here. There are 2 branches. Now, the bigger we go in the value of the function, the outer the level curves go till they touch the point. When it's 4, and there is your maximum, because if the function increases in value, it comes out of the restriction. And the same for the minimum, there is your minimum. And that's how the Lagrange multipliers are understood in terms of level curves.